integers nums and an integer target, return the indices of the two numbers such that they add up to target. You may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. So for the first one, we have 2, 7, 5, 2, 7. I don't know where I got 5 from. 11, 15, and then the target is 9. And our output is 0 and 1 because when we add 2 and 7 together, we get 9. So the index here is 1 and 2 because we have 2 plus 4, which is our target 6, and then 0 and 1 here because our target is also 6. So brute force implementation would be 2 for loops. We would iterate over the array and then, just check whenever we get a sum, which would be our I and our j index matched together, we would just return it. So luckily for us in this example, the first time we do it, it would add together. So our time complexity is O of n squared, and then the space is going to be constant. So we could just implement that. And then a second for loop where, since we cannot use, where did it say it? We're going to assign j to I plus 1 because we'll have exactly one solution, and we can assume we may not use the same element twice. J is less than nums of length, j plus plus, and then we can grab our sum, which is going to be nums of I plus nums of j, and then we'll say if our sum matches our target, then all we have to do is return I and j. And if we run it, sweet, we're passing. So the question of algorithms and any algorithmic question is, can we do better? And we can. We can actually improve our time complexity by using more space, and that would be using a hash table. And so with a hash table, we will just iterate over the array, and if we don't find an element, what we're basically trying to figure out is if we can have our target. We're searching for our target minus our current element. And if our hash table has this, then that means we have found the sum of our two numbers. And so iterating through this, we'll have 2, the first index, we'll have 2 and 0, and then we'll look at our map, our hash map, we won't find anything, so then we'll move our index over, and then we'll say, okay, does our hash map have, being our target is 9, do we have 9 minus 7, which is going to be 2. And so because we have that, that's actually an element in our map, we will return the index, which will be 0 first, and then the index 1 here. So our time complexity will be, time and space complexity will both be linear, if that makes sense. So we keep going. Create a map. Going to use the map value because for objects, we can actually skip over 0 since everything gets converted into a string versus using the map object. Numbers will stay numbers, so we don't have to worry about skipping over 0 or other elements. So we're going to check if our map has our target minus our nums of I, then we will return an array of our map where we get our target minus nums of I, and then I. Otherwise, we need to hash the values, so we'll set nums of I, and then our current index. Very cool. Sweet. And that is the optimal approach. Like, comment, subscribe, and I'll see you in the next video.